Good evening. Some time has passed now since my last video about the Roetest, my Roetest build. In between the time I used it a lot, tested a lot of tubes, but I thought it was time to make a new video. The reason is, the most important reason is that I had an issue, or I still have an issue. So this will be more a troubleshooting video, plus some showing of what I did additionally. But let's come back to the troubleshooting. After a while of testing, suddenly I had a blown fuse. And this was the fuse that was responsible for the positive 12 volt rail, from which the positive 5 volt CPU digital rail derives. I don't know if you can see it. Let me see. It is that fuse where the clips are on at the moment. It is a 200 milliamp fuse, slow blow. And the interesting thing is, the fuse doesn't blow immediately when I put a new one inside. It blows after a few minutes. So after the second fuse after I changed the fuse and it blew again in a few minutes, I started to check what the problem is. I inserted a new fuse, and in series of this fuse I put my multimeter that you can see here in AC mode, AC amps mode, in 600 milliamps mode. And because the fuse doesn't blow immediately, I could see what the current was drawn at that time. And I was over 260 milliamps. So that's normal, that the fuse will be blown, not immediately, because a slow blow will take some punishment till it goes. Yeah? From the beginning of the build, I had some not really cozy feeling about this transformer here. This is the transformer that generates the 12 volt for the 12 volt positive rail and the 5 volt rail. And about this regulator here, that's the 5 volt regulator for the logic. For my taste, they were getting a little bit too warm. The other side, I thought, okay, everybody that builds with linear regulators comes from the 80s, and I know that from other equipment, expensive equipment, for example, like Keithley. I have a Keithley 2000, 6.5 digit meter. The regulators, the linear regulators, 7815, 7915, 7805, they're getting so hot that you cannot even touch it. It's not unpleasant, it hurts. And the best thing is, they are extremely near to the electrolytic bulk capacitors. Of course, the capacitors are Gonski after these years. So I thought, okay, it was how they built from that time, and the design is a little bit from that time, or a few parts at least. Nevertheless, now that I found that 260 milliamps is the reason, I started to check what is happening. And here is the schematic. This is the transformer that gets warm, and this is the fuse that gets blown, 200 milliamps. It is used to generate the positive rail for the 12 volts, positive and negative rail from the same transformer, but different fuses. And the 5 volt CPU digital voltage derives from the 12 volt regulator. Well, okay. Anyway, this is getting warm, this is getting warm, and this is getting blown. So I checked the voltage, I checked the regulators, everything, it was okay. At the end, I started troubleshooting it and had to find out which card or which cards are drawing the current and making the bad. I found out that the problem is with the relay cards. I had some relay cards that you can see here that were drawing excessive current. For example, relay card 3, it was drawing 30 milliamps. This card shouldn't draw more than 10 to 15 milliamps, max. Yeah? I had relay card 8 drawing 90 milliamps. And at the end, the topping is relay card 10 that was drawing 120 milliamps. So put it all together, I was a total of 261, not 161. I had a total of 260 milliamps. This is the reason why the fuse was blown all the time. That was a month ago, more than a month ago. I changed on cards 8 and 10 the PCF 8574 because this was a problematic IC that was drawing the current. I'm using the ones from Texas Instruments, the N versions at the end. I had only 2 of them, a normal one and an A version. So I changed it for on the cards 8 and 10 that was making the biggest issues. And I left the one on the third card as it is till I receive the ordered ones. I brought it down to 161 milliamperes. That is well under the 200 milliampere fuse, so it worked. I received now the new PCF ICs from another distributor. I want to mention that the ICs I used from the beginning are from a German distributor, not a big distributor like Mauser or Element 14 or DigiKey, etc. But it's a German distributor, a well-known one. So I don't think he will see selling crap. The problem is even distributors at these days, at these years, they do not really know from where the stuff is coming. Anyway, just for fun, I mailed Helmut and I wrote him about this problem and I asked him if he ever heard about that. The answer was very interesting. He said, we have a lot of problems. These problems occur quite often, but only with the Texas Instruments version of the PCF 8574 N version of the chip, N or NA for the extended address. All other people that are using the, let's say so, the old PCF chips from Philips or NXP, because Philips NXP was the company that first designed these chips, there are no problems at all. So okay, I received it, and now I wanted to change just on card 3, the chip that was drawing 30 milliamps instead of 10. And look what I'm seeing now. I have again a problem. One of the chips, there's an additional chip that is drawing too much current. And I already found out which it is. It's again card 10. Where I use the AN version from the German distributor. And I'm almost at 200 milliamps. And it's only a matter of time till it goes up again and my fuse will get blown. So I will replace now the chips from card 3 and 10. And let's see what happens. Okay, I replaced both of the chips and then down to 166 milliamps. That's well below, but still I don't like it. I think it's a little bit too high. Now that the troubleshooting is done, I added additionally an auxiliary power supply. It's upside down now. Dave Jones would say all the electrons will fall out, but anyway, it's a 12 volt switch mode power supply, 2.1 amps for the auxiliary regions. On my socket box receiver PCB, I have added this connector for the auxiliary 12 volts for everything that is in case necessary in the socket boxes for the future. I could use, of course, the 12 volts from the unregulated 12 volts from the relays, but I do not want to use anything that is a part of the main board in case that something catastrophic happens. So this is why I added an additional power supply. I found a free hole here that I used. Thank you, Helmut. And this goes at the front side to the socket box receiver case that we will see in the next video. Further, I ordered from Helmut the latest software, the latest version 9.7 for my release, for my hardware version 9. I will replace it, and of course, unfortunately, I have to make the complete calibration again because the ADCs, analog digital converters used, are on the microchip chip. So, okay, that's for now. Cheers.